But go ahead and point to the person you're gonna be working with during this time. Perfect, you guys have a little triad going on back there, that's perfect. So when you're working together, just a couple of expectations for me is that you work together, that you both talk through the math and talk through what you're thinking, and then on the grids, if you're shading anything on the grid, you kind of take turns with that and talk about what you're doing and why you're doing it and those kinds of things. So I'll be putting a problem up for you all, and we'll talk through it, and then I'll let you go to work, and then I'll be coming around asking you questions. We have the iPad back there because they're videoing me teaching, and Mrs. Gobble will probably be walking around when I'm coming to visit your group so she can hear me what I'm saying. Sound good? And then after we get through exploring the math, we'll come back together. I'll be taking pictures of your work and putting it on and showing it on the screen if I can figure that out. So you might need to help me out on that. From me, I'm right. Is that what I need to make sure I have on my? Yeah, where you're good. That's what I. I'm just going to walk back.
Like, sit down next to me.
No, but thank you.
Sure. I'll be glad to be with you.
That was our take the wheel there. You guys are really testing.
I try to move the single chair.
I don't like the cherry with the Dr. Pepper, but I'm an originalist.
Yeah, yeah. But. Okay.
We're here.
Perfect. All right, guys, I think we're ready to get started this morning. So we're gonna look up on the screen. I'm gonna talk to you about what we're learning today. And then I'm gonna get you in on that map and let you work with those place value chips and those grids that we talked about earlier. So let's talk about what we're learning today. So our learning target today is that you are learning the meaning of the digits in a decimal number and how they're related. So you're going to be talking about what those digits mean in those numbers. I know you know some things about that because you probably learned that earlier in the year. But you're going to be talking about and thinking about what do those digits mean and how are they related to each other. Okay, so that's something you're going to be talking about today. You're going to know you're successful when you do these things. Okay, you are going to create a model and an equation to represent that number, and you've got to be able to explain the models. So as you're working, if you're like, I'm done, I want you to think about our success criteria. Have you modeled it with the chips and the place value grids? Have you written an equation to match the model? And can you and your partner explain what your models mean, how those digits are related, okay? So that's kind of how you keep track of how you know you've learned today's learning target, mastered today's learning target. Any questions? I look super excited early this morning. So I want to explain the grids for you really quickly and talk about what you see. So you don't have a whole grid, just a plain hole. All of your holes are already partitioned. So I want you to look at this grid. You have that on your table. So everybody, if you want to just kind of look at that real quick, tell your partner what that's partitioned into and how do you know? The one that's on the screen right here. Talk to your partner. What is that partitioned into and how do you know? All right, come back with me. What do you think about this one right here? What is this partitioned into? Tens. How'd you know that? You counted because there's 10 equal pieces, right? So it has to be a tenth. So if I shake in one of these, we have 1/10, right? What about this next one? And this next one, I'll let you talk about these together. These two different ones. I want you to talk about these two What are they partitioned into? How do you know? And ones that will shake. What about this? Oh, wait a minute. There we go. Easier way to count that. Right. Okay, let's come back again. So you have your other grids. This is, you said this was 10, those were 10 equal pieces. Uh-oh. Well, there you go. Wrong way. Can't touch it, right? So what did you say this one was? 100, because there's how many pieces? 100. Did you count them all? No, maybe you did. How did you count them all? Did you count every single one? Oh, that took a minute, didn't it? What about this one? 1,000. Now, nobody counted all of those yet, right? But we could count them in a more efficient way, right? Just skip counting, count by tens. And so while I wanted to make sure we understand the grids before we got started using them today, because you're going to be using them to model the number. Remember, our success criteria today was to model the number. You got to use these grids and the chips and to write an equation that matches these models. Okay, and we're thinking about how the digits are related. So let's look at our problem that I need you to talk about. So we're going to make this number with your partner using some chips and grids and write an equation in expanded form. Okay, I think you guys have been talking and know about expanded form. So as you're working together today, I want you to model it, write an equation, and be able to explain. Tell your partner what 3 things you have to do to be successful today. Okay, so come back with me. Got to model it, write an equation, be able to explain, right? What kind of equation? Expanded form, expanded notation equation. So here is our number. Anybody want to read it? Yeah, what is it? 2 and 222,000. So what I want you to do for the next 10 minutes or so, I'm gonna set my timer, is work with your partner to model this number. Remember, what we're trying to learn today is how these digits are related to each other. And we're going to talk about how they're related to each other by modeling and writing some equations. Are you ready to roll? Awesome. Okay, so I'm going to set my timer. You and your partner can get the chips out and you can talk about how you can model this number.
The blueberry.
Okay, how did you say you needed 2 of those? Why do you need 2 of those? Okay, so which number of your coach you needed 2 of those? Oh, the line, okay. And so why do you have 2 of those? Okay. So do you know how to look at your grid? Like, your grid, which one of these grids do you use? So what I want to talk about is once you get this your chips model out the way you're doing right now, you're going to read it out with us together, right? All right, talk to me, guys. What y'all doing over here? What you thinking about modeling our number? You're confused. Well, talk to me. You're confused. Everything. Okay, so tell me what you know about those digits, about 2 and 222,000. I'm sorry. Which 2? There's a bunch of 2s up there. Are there all 2s? So which 2's in the thousands? So the one in front of the decimal. What do y'all think? Y'all think the 2 in front of the decimal? Did y'all hear what she just said? Why does she think this is 2? Did you hear what she just said? What did she just say? 2 of each. So this 2 is 2 what? Holes. And the number up there in our number, which one of those is holes? The first number, right? That first number is your hole. So which one? She has 2 tenths. Which one of those are our tenths?
Of course, right?
Okay, y'all following this?
You know why?
So let me ask you a question. Remember how our learning target for today is to figure out how these digits are related to each other.
Right.
So what does the two tell you? That there's two groups of each one. What I want y'all to think about, remember we have to write an equation to model our number. The word groups of, what does it tell you? You're doing an equation. I said write two groups of multiplication. Okay? So how, I want y'all to talk about it. You can write on the back of the paper if you want. How could you write a multiplication equation that shows your number? The total value of the number. So y'all talk about that equation. What does it look like? Remember the word groups of and how that can help you, okay? I'll come back check with you. All right, guys, talk to me about your model. Really good.
Well, if.
Oh, how are they related?
Because 100 is 110. The 10 is going backwards if you go right. But if you go left, 10 times.
Okay. Y'all hear what he said in the group chat? So he's saying it's 1/10 if you go right, that it's 10 times if you go right. But how could we prove that? How could we prove it? Because these look exactly the same to me. How can something that has, they all have two, right? So how can we prove that this is a 10th of this? Okay. It's kind of like money. They're not, you can't, like in a base 10 block, we could show it. Could you use these grids? Could you use these grids to show? So I want y'all to talk about that. Since you already kind of know that it's 1/10 of or it's 10 times. How can this grid here, or this, help you show that this number to the left is 10 times greater than the number to the right, or vice versa, that this number is a 10? Okay. So look at those, I want y'all to talk about it. How can this help you prove that, okay? And then I want you to think about what equation that is. I'll come back and check on it. All right, I just got things. Okay, what are the twos telling you? What does that first two tell you? 2 holes. So which chips show you 2 holes? Perfect. Can you lay those out? What does the next two tell you? Okay, so you can show me that. I'm gonna lay them out like this if that's okay. So we can see what. And then the next one is 2. Okay. Is that 100? Oh, yeah. Yeah. And then the last 2. Perfect. Lay them out there. So the 2 tells you, I want you to use the words groups of. What does the 2 tell you? Use the word groups of and tell me what the 2 tells you. There you go. There's 2 groups of thousands, 2 groups of hundreds, 2 groups of tens, and 2 groups of ones, right? What I want and wondering about, because remember part of our success criteria is to write an equation. That word groups of, right? What does groups of mean to do? So I want you and your partner to talk about how could you write an equation that shows the value of this whole thing using groups of. How would you tell me in an equation 2 groups of 1? What would you write? You could write 1 plus 1. But what is the word groups of? Multiply. So could you use multiplication? What would the multiplication equation look like for that? 1 times 2. 10 times 2, right? So you keep going. So I want y'all to work together to make an equation. If you want to just write on the back here. What would the equation look like to show the value of each of these numbers and the total value? Talk about that. Okay. So why did you put 2 in each one? Okay.
That's one of each.
So use the word groups of and tell me what that 2 tells you about this. So 2 groups of a whole. And this is, could you tell me 2 groups of what? A 10. Right, you said it. And then what do you think? 2 groups of, what does this show? 2 groups of 100, right? So we have our groups of. So did y'all model it with your chips? Oh, so you got your chips down, right? You knew that the 2s told you how many groups of each chip place value you have, right? So let's talk about that. So part of our success criteria was to model. You modeled here, but we also want to model here. And remember, we didn't have an actual whole of that. But could you show this value on one of these groups? What would you do to show the value on one of them? Okay, gotcha. So I want y'all to keep that thinking, because we won't have the holes. We'll just talk about this side because we didn't get a hole. But showing the value of all of them. Once you start shading and talking about which one of these shows value, I want you to think of an equation that you could write that would also show the value of the whole number together, okay? And I'll come back to it again. All right, guys, how's it going back here? What, tell me what you're thinking.
I don't know if you,
Nice. Why did you do that?
because each were 2/10, 200, and 2,000.
Okay.
And then this is a little inflated, and then we make an equation out of this.
Oh, nice. So tell me, the 2 told you what? The 2 in all those place values, what did it tell you?
Two shaded, 2 and.
I want you to use the words groups of. Y'all hear groups of? Tell me what those 2s told you using the word groups of. It tells you 2 what? So that told, this 2 told you that there were 2 groups of a whole, right?
Yeah.
This said there were, keep using the word.
2 groups of 1/10.
Okay, 2 groups of a 10, right? And then keep going.
2 groups of 1,000.
Gotcha.
No, not 100.
Oh.
2 groups of 100.
Right.
2 groups of 1,000.
Gotcha. So, and then you wrote this equation and you wrote 2 plus 2 10s plus 200 plus 2,000 is your total. So I'm wondering if there's another way you can write this equation using the words groups of those. What does the word groups of mean today?
That means like put them into little sections.
Yes, and what operation?
Expanded.
Oh, it is. Like this is expanded form and there's another expanded. What operation would you use? Yeah, well, there is word form. We could write that word form. But if I said, what operation? Multiplication, division, addition, or subtraction. What operation would mean groups of? So you said this was 2 groups of 1, right? So what I'm wondering is, could you write, oh, we got about 3 or 4 more minutes. So keep exploring, get into our learning target for the day. Have you figured out the relationship between the digits? What is the relationship? Could you rewrite this equation underneath it? Using multiplication to show the value of each thing. I want y'all to think about that. I'm gonna come back. But I also remember that part of the learning target. How does this number relate to this one and this one relate to this one? What's the relationship? And I'll come back to it. Hey, did y'all come up with your answer? You're done. Talk to me then. What did you discover?
I don't want me to go share.
Uh-huh. Okay. Okay. Oh, I see. So your 2 told you there were 2 groups of each of them. That's what you're saying to me? There's 2 of those? Could you show me that 2 here? Where would 2,000s be on this group? I mean, I know you put the chips there, that's right, but in the shade, how many pieces are in this group? 1,000. How could you show me 2 of them? Oh, what's he doing? How many is he shading over there? 2 of the thousands. Uh-oh, what do you think he's gonna shade now? Oh, why is he doing that, y'all? To make more thousands, right? So here's my question. Remember, part of our success criteria was we have to know and learn about the relationship between these digits, right? So what is the relationship? How is this 2 different from that 2 and the same? How are they the same? How are they different? How are they related? So how could you prove that? How does your model here prove that? It does definition 0, but with our model, how does our model prove that this is 10 times bigger than this?
What?
How many thousands are inside of this little square? 10, right? 10 thousandths in there. How many hundredths are in one of these tens? 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I'm wondering is, since we're talking about the relationship, you already said it was 10 times greater to the reality of that 10th of 10, right? Could you just use this group to model the two? You can't model the whole because I didn't give you enough whole. But could you model the 222,000 just using this group? And talk to your partners. What would that look like? I want to see it.
Those two relate.
We got her.
I'll try my best.
So how is that two? So tell me why you shaded these in. When she said 1/10, I'm interrupting, I'm sorry. She said that it represents 1/10 of. How does she know it's 1/10 of? Okay, but what is 1/10? Say it again. This little bitty one is 1/10 of this big square. Is that what you're saying? Is that what you were saying? Do y'all see that? So these little teeny boxes in here are 1/10 of this big square. What's this big square called? 10. That's right, 100, right? So we took this square here and look, we cut it into 10 pieces. So this is 1/10 of this. So you were talking about related. How are they related? 1,000 is a what? Yes, this was 10 times greater than this one, right? And so that's their relationship. This is 1/10 of, but not because I said so, because there's really 10 of these in here. Look how many of this one. How many of these are in 1/10? 10. Right, 10 hundredths make 1/10. So I want to take a picture of this. And I kind of threw you off because I didn't give you a whole to model. So when you were modeling your tenths here on this one, I want y'all to think about an equation. Remember, other part of our success criteria. You have an equation? So interesting. So 1 and 111 thousandths times 2, she just doubled it, didn't she? Look, she took that one and she doubled it. I like that thought. Here's what I wonder now. Can you write an equation showing the value of each place and add them together rather than the value of the whole number? That's what I want you to work on. Let me take this picture right quick. And then I'm only going to that. I'm going to put the link there.
Wait, I want to say this again.
Okay, so y'all think about that. How do you write equations? Did y'all come up with your equation? You did? What'd you come up with? Okay, what would it be? Did you hear what he said? If I put this over the light, do you see 10 of those in there? So there's 10 hundredths in a 10. Look at that. So the relationship y'all discovered was that there are 10 of those, 10 hundredths in a 10. What about the relationship between the thousands? Yeah. Awesome. So the last part of your secretary was to write that equation. Okay, so can you write an equation showing the value of this and the value of this and the value of this, so you can show the value of the whole number? What would that equation look like? Write that out. We're almost done. Y'all come up here. Interesting. Why are you writing 1/10 times 2? So this 2 represents 2 tenths that we're writing, right? And so I love your equation. What I want to do is it match your model. I Oh, yes, you're absolutely right. I probably should have given them a whole. You can't make a whole, so let's just talk about the 222,000. Could you use all of these grids or just one of these grids to make 222,000? I'll talk about that. Where, did y'all get your equation? Then I was talking to sure. Okay. So you're, oh, here. You model that. Did you come up with your equation? For the whole number? Okay, so it's 2,000. What I'm gonna do is put all of those values together. If I said what's the value of this whole number? Yep. Gotcha. Okay. So you got your poles. What I want y'all to try to do together is to talk about how you have these pieces of equations. Can you put all the equations together to show the whole number? What would that look like? And if you guys get your equations. You're not exactly. Oh, good, yes, you did. So tell me why you chose to, we were talking about why to write it as multiplication.
Well, one is, well, one.
Uh-huh.
You gotta multiply it by two.
Gotcha. So it was, because it's two, use the words groups of.
Two groups of.
Oh, and the other one was two. There you go. You got it. Good job, guys.
You know how they
Oh, tell me.
this one is 1/10. That one is 1/10.
Why is it 1/10 though?
Well, you gotta divide by this one.
Yeah, because how many of these would fit in?
10.
10. So this one is a 10th of that one. What's this one of this one? Is it a 10?
No.
It's 10 one.
10
times greater, right? So it's 10 times greater when you have only 10. Good job. All right, guys, let's come back together. We're going to share some of these. Might be, or tell me what to push. As well as get a try to put some of your solutions up here for us to talk about. You guys did an awesome job of getting to our learning target for the day, which was to explore the digits of a decimal number and talk about how they're related. You were modeling like crazy. You were writing equations. And you were writing equations and you were talking about the relationship between the digits. So I am so impressed with you all. You're definitely about to go to 6. I know. So what we're gonna do is look at some of your solutions that you have and we're gonna talk. So if you will just put your grids and place value chips down. We'll look at these models and we want to be respectful of people's work. So we don't want to be writing or talking while we're showing other people's work, okay? And I'll okay. All right, first of all, I want to show this one. And I want to try to flip it. Love it. There we go. And then did we figure out that if I let this go, if my phone goes dark, will this go away? I've got to keep my phone open, right? Okay, just making sure. So let's look at this first model. And I saw this in almost every person's group that I went around to, every group's model. I want you to talk about why they chose to put these digits and in this order. Turn and talk to your neighbor. Why did they choose these digits in this order? Okay, let's share back out. Somebody tell me why they chose these chips and why they put them in this order. What do you think, hon?
Because you're getting more pieces each time.
Oh, is it getting more pieces each time? Y'all agree with that? No,
Like
why?
getting less.
Oh, so I'm confused. I hear that it's getting more pieces each time, but then I hear, no, it's getting less pieces each time. Which is it? Turn it on your neighbor. What do you think? And why?
Yes, if you get like 0.1,
Okay, all right, let's go back again. So we're having some debate, a little disequilibrium there. People were having a little discussion, a little argument, had a little good math fight. You like a little math fight? So I heard that we were getting more. I heard we were getting less. What did we come up with? Who wants to share on what's happening with these ships and why they? You want to share? What was it?
That it's not more chips, it's just, like,
Did y'all hear what he said? There is not more chips. It's just a different amount that the chips are showing. So why did they all choose to put 2 of each of these?
because there's 2 in each.
There's 2 in each of the place values, right? So turn and tell your neighbor, the 2 in each of those place values told you what? Turn and tell your neighbor, what did the 2 in each of the place values tell you?
Said it was. Because I would try this.
One, two, three, four. Yeah. All right, so let's come back again. Why are there 2 of each one of these? Because the 2 told us what? The 2 in our number. Who can share that?
It showed you this.
Okay. It showed there were 2 of each of these. But what's different about them? The 2 tells us what? Yeah. Okay. Each one is a fraction of the whole. We were talking about how the numbers were related, so we want to get to what she's saying here in just a minute about one's a fraction of the other. So we'll talk about that in just a second. But those 2s told us, can you tell me what you guys were talking about when y'all were using the word groups of? The 2 told you. You forgot, can somebody help her out here? We were using the word groups of a lot in our discussion. Yeah, help me out. Yeah, groups of means to multiply. But in our 2, that 2 decimal 222, the 2 told us there were 2 groups of.
A whole.
2 groups of.
A 10.
2 groups of. So the 2's just tell you how many groups of the digits there are, right? Of the place value there are. So the difference you said was that they're the size of those. Isn't that what you said? That the size of this is actually a 10. It doesn't look different here, does it? They look exactly the same, so I'm confused. So is the relationship is that they're all absolutely the same? This 2 is the same amount as this 2, is the same amount as this 2?
No.
No? Well, let's talk about that. So let's look at a different model. So we talked about the 2 told us the number of groups in the, let's see. Let me get to the right one. Oh, here we go. The one I want to show. Okay, are y'all there? I think it froze a minute ago. So when they were shading these in, so we had our, and this loves to give you a hole. Remember I told you there were no holes? So they're missing the 2 holes. And we're just gonna ignore the 2 holes for right now, okay? Pretend they're over here on a big square. We're only talking about the 222,000, right? So where do you see that same model from here? Minus the holes. Then they're not there. Where do you see this in here? What's the same, but what's different? Turn and tell your neighbor, what's the same and what's different? Okay, so let's come back again. Remember our first model was this one, and we want to talk about how is this one the same and different. So who can share what you and your partner talked about? Who can share what you and your partner talked about? Yes, sir. There's 2 on each one, just like our chips, right? Because the 2 tells us how many groups of each place value we have. But what's different about these? Oh, the way you show it. So what does this represent? 2 tenths. Y'all agree? What does this represent? And this? 2,000. So if we put all those together, what's the value of this whole thing? right? So the difference is, you guys told me the size of these pieces. So remember, part of our success criteria and our learning target for the day is to talk about how they're related. And I heard y'all talking about fractional pieces and all of that. So I'm wondering, how are these related? So let me look at the next solution for us to share. It is right here. And that's a little more difficult to see. And think about that last, sorry y'all, I'm spinning it too much. The last model we just saw where it was on 3 different sheets, and now what is going on here? Does this show the same as our last model? Try to talk to your neighbor. Does it show the same? If it does, how? If not, why not? Y'all think it does? So where are the 2 tenths?
But it's not as
Yeah, so they have these, right? So how many hundreds are in here? 2. So this is 200. How many hundreds are in here? Look at your mom. This is 200. How many hundreds? How many of these are in 2 of these? 10 here. 10 here, right? See that? Can you see that in that one? Okay, let's come back together. What do you think? Does this show the same thing or not? Oh, and here's some yeses and some no's. I like a good math fight, so let's argue about it. So what do you think? Who wants to talk about their thinking on why it is or isn't? You're volunteering your friend here. Would you like to share, honey, or no? You don't have to. Would you like to? Not right now? Okay, who does want to share? All right, talk to us.
Well, I think it's the same amount, but just shown in a different way.
Oh, how many people agree with that? Okay, who wants to argue that that's not right? Now, we all agree now? So that's true. Where are those tenths? Turn and tell your neighbor where the tenths are. Because we saw 2 tenths, where are they? Okay, so let's come back together. Where are the 2 tenths?
On the large.
Can you see them? Do you see this tenth and this tenth?
Yes.
Yeah. So remember in our picture we had 2 tenths, so we see them here, right? And how many hundredths are in there? 10. How many thousandths are in there?
100.
Oh, so how are tenths and hundredths related to each other? Try to tell your neighbor, how are the tenths and hundredths related?
Yeah, they're
All right, let's come back together. Could you share what you guys are talking about how they're related? He said that the 10 is 10 times greater than the 100. Because how many did you say were in there? 10. Did y'all see that relationship? That the 10 is 10 times greater than the 100 because it took 10 of them, he said. Because we always hear that, oh, it's 10 times greater than the 10th of. Okay, great. But what does that mean? Right? It means that there's actually 10 of them that it takes to make one. In the thousandth, he said the same thing. He said in a thousandth, this thousandth right here, it took 10 of them to make 100. You agree with that? So we see the 10 times greater. If we're going the other way, you guys were saying it's a 10th of, because this is a 10th of 100. If we were doing fractions, we'd shade that in and say 1/10 of 100, right? So let's keep going. You guys said this was 10. You're discovering a relationship about them being 10 times greater or a 10th of. You said this was a 10th, and then we had 200. Do you see the 200s on here? Turn and tell your neighbor, do you see the 200s? And where is it? All right, so let's come back together. Where is it? What were you saying? Say that again? There's 3 instead of 2, did y'all notice that?
Yeah. Yes.
So those of you who were saying, remember that math fight we started earlier?
Yes.
Where you guys were kind of arguing of, no, it's not the same. Some of us were saying, yes, it is the same. Maybe we didn't notice we accidentally put in an extra 100. That happens, right?
Yeah.
But those of us who really paid close attention knew that there should have only been 2 100s right here, and this one should have been changed. But you see the 2 100s, it's got the 10,000s in it. The 10 1,000s, the 10 1,000s. And then there are our final 2 little thousands. So we ended up showing the value of both of these that way. So our last part of our success criteria was to write this as an equation. Y'all remember that?
Yeah.
So I want to show flashes. I'm always like, why can't I see? Because I don't have my phone. So I want to show this one first. Let's see it a little bit. Okay. Oh, that's hard to see. Oh, look, I made it really good. So look at this equation. So you guys have already talked about that you knew how to model, and you were talking about the relationship between the digits. You discovered that 2 means there's 2 groups of each place value. You've discovered that 1/10 is a tenth of a whole. You discovered that 1,000 is a tenth of 100. All these things you discovered. Now the last part of our success criteria was the equation. So let's take a look at this. You see these 2 different equations here?
Yep.
Which one's right? Turn and talk to your neighbor. Which one's right? What do you think? Hey, they're both right. How can they both be right? That's not possible. Yes. You can't. Because what did that 2 tell us? What was that word I kept telling y'all to say? Groups of. You know how we share it? Alright, let's come back together. So which one's right? In math, there could be 2 answers? Of course there can, right? So you're saying they're both right, but okay, explain to me then, why did this, what does this represent, first of all? The 2 holes. What does this represent? Right? So just like our chips, except this time it's not showing the groups up, it's showing how much it's worth. Right? When I put, like, if I give you 2 dimes, you have 20 cents, right? If I give you 2 nickels, right, you have 10 cents. If I give you $2, you have $2. This 2, even though I gave you 2 of everything, you all got different amounts, didn't you? So 2 of these is different than 2 of these. So this is showing the value of the place, right? Not how many groups there are. So what's different here, and why did they choose to write that? Yes, talk to me. Do y'all agree with that? Hear what she said? That they're saying 1 times 2, 1 group of 2 or 2 groups of 1 is 2. 2 groups of a tenth is 2 tenths. So we were using that language of, what do we call this versus this? When y'all been learning that this year, do you know the difference, what we call this? Expanded form. What's this one? Is it also expanded form?
Yeah.
Pretty much. There's a little bit different word with it. We put expanded notation. So when you have expanded notation, you're showing the number of groups of the value, right? So you all discovered this 2 is 2 groups of a tenth, which makes it worth 2 tenths. This 2 is 2 groups of 100, which makes it worth 200, right? So if I said, I'm gonna give you all 2, you would say 2 what? $200, $2, 2 dimes. There's a big difference, isn't it? Right? So even though they look all the same, they're not. Yes, sir.
Well, I'm confused about why does it say 2 plus 2?
Oh, sorry. Hang on. What you're confused about is why does it say 2 plus 2? Where is it at?
Okay. 2 plus. I see
Here?
plus 2 tenths.
Say it again.
That's 2 plus 2 tenths.
2 plus 2 tenths. 2 wholes plus 2 tenths plus 2. Is something missing, honey?
There's a decimal, there's a decimal.
Oh, somebody put the decimal there. Do you have to get the decimal after a whole number? No, you don't have to, but you could do 2 decimals in a row if you want. Okay, last thing that we want to talk about, okay, is this last equation because it is strange. Well, I don't know, why did they write it this way? What were they thinking? It's not strange. It's great thinking, actually. Look at this. Wow. Hold on a minute. I thought we said that we already had expanded form and expanded notation. What were these people thinking when they wrote this equation? And is it right?
Yes.
Try and talk your name. Yeah, what makes it, how does it work? Okay, so what do you think? What was this group thinking when they wrote this expanded notation? Yes, sir.
It's one has, within it, one has two, the other is the whole, or the two,
Two groups of one whole, keep going.
and there's two groups of 1/10, two groups of 100, and two groups of 1,000.
I thought we were doing decimals.
They thought the fractions and decimals equal the same thing, which they did.
There you go. He was like, which they do. Because fractions and decimals are the same thing, aren't they? They're pieces of a whole, right? So either whether we wrote this equation or this one, that the only difference is this 100 is written this way, and on this 100 it's written this way. Same thing, right? So you guys were able to today come up with equations to show the value of 222,000. Excellent job. You were modeling what the value of each of these digits was. And most importantly, you found out what the relationship between the two, or between all of the digits is. So I want you to punch that home with your partners and talk about what was the relationship. But I want to show you what our friend discovered over here. Did anybody discover this earlier if you laid these on top of each other?
Yes.
And looked up at the light? That you could actually see how many were in each one? So if you had, you could do that later. But here's what I want you to wrap this lesson up with telling your neighbors. You've done all the modeling. You know that the two represented the two groups of. The only difference was the value of the digit, right? But what's the relationship between all of those digits? How are they related? Talk to your neighbor. Yep, so that first two is it 10 times greater or 10 times? Talk about that, how are they related? Okay, so let's come back together. And let's talk about what was it we discovered about these digits in this number? Here, I'm gonna try to pull it up. Just the sum here. What's the relationship between this two and this two and this two and this two? How are these all related to each other? Yes, ma'am. So when I go this way, I'm dividing it by 10, or taking a tenth of it, aren't I? So if I took that whole and I divided it into 10 pieces, I get that sheet of tenths. If I take that 10th and I divide it into 10 pieces, I get hundreds. If I take that 100th and divide it into 10 little teeny weeny pieces, I get thousands. And in this case, 200,000 is a tenth of, or 10 times greater than 20,000, which is 10 times greater than 2,000. So we can really see that value. You guys are rocking it. I love getting to teach in your class today. You definitely met your learning target of being able to model these numbers and explain the relationship between them and write it in the information. Good job. What I need you to do now, we're going to do an exit ticket to see how you can apply that to a new problem. If you knock it out here. And we will we'll wrap up today. So if you would put those chips back in the bag if you haven't already, and I'll take those up from you. You're welcome to keep those grits if you want, or you can trash them later on today. You might need to bring your exit ticket. So, and actually, you could write on the back of one of those grits for your exit ticket, or if you have paper nearby, you can write it on a piece of paper. That's it. So here's your exit ticket that everybody should be responding to, either on a piece of paper or on the back of one of those grids. Put your name and then answer this question here. In which number does the digit 5 have a greater value? So which one does the 5 have a greater value? In this number or in this number? And how many times as great as the value, and explain how to do that. Okay, so y'all work on that as your exit ticket. Thank you so much for letting me come to your classroom today. Hope you have a great rest of your day.
Thank you again.
Not today, no, but